Hello and welcome to the next in our Weather Unlocked video series. My name is Gene Hatch, one of the meteorologists at the National Weather Service office in Springfield, Missouri. During this video, we will discuss some of the types of weather that can impact our aviation community and partners. Weather can have a significant impact on aircraft operation, which pilots have to understand and deal with. The atmosphere is a pilot's workspace, and just like any other job, understanding where you work is important. There are many things that can impact aviators other than just thunderstorms, including clouds, precipitation, and fog. Icing, turbulence, and low-level wind shear can also sometimes have severe impacts. Even extremes in temperatures can have an impact. Clouds, fog, and precipitation can all significantly impact pilots and flight safety in various ways. Clouds, such as stratus and fog, can severely reduce visibilities, making it difficult for pilots to navigate visually, especially during takeoff or landing. This can require pilots to rely on instruments. Fog can drastically reduce visibility to near zero in some cases. This can make takeoff, landing, and even flying at cruising altitude difficult if airports do not have proper low visibility landing systems. Precipitation, especially heavy rain or snow, can severely limit visibilities, which makes it difficult for pilots to see other aircraft, the runway, or terrain. This increases the risk of a collision or other accidents. In all these cases, visibilities and a pilot's ability to see the runway during landing can be impacted. Icing can occur in certain types of clouds, especially those containing moisture at colder temperatures, like cumulonimbus, which can lead to ice formation on the aircraft's surfaces. This can affect the aircraft's performance and handling and requires de-icing systems. Icing can occur if an airplane passes through a cloud when the air temperature is at or below freezing. This can happen during widespread rain, scattered showers, or even in a thunderstorm. This is hazardous to flight because it can cause increased drag and weight on the aircraft and also decrease lift. All of these effects can degrade the ability of an aircraft to maintain altitude. Depending on the temperature and the moisture content of a cloud, different types of icing can occur. The three types of icing are clear, rime, and mixed icing. Clear ice forms when supercooled water droplets freeze on the aircraft's surface. It typically occurs when the droplets are large and the temperature is just below freezing. Rime ice forms when smaller supercooled water droplets freeze rapidly upon contact with the aircraft's surface, usually at temperatures between -10 and -20 degrees Celsius, and has a frosty, opaque appearance. Mixed ice occurs when both clear and rime ice are present on the aircraft at the same time, especially in environments where there are varying temperatures and a mix of different sized water droplets. Mixed icing can be particularly hazardous because it combines the dense and hard characteristics of a clear ice with the rough texture of rime ice. It can disrupt airflow, increase drag, reduce lift, and significantly affect the handling of the aircraft. Turbulence occurs when there are irregular and chaotic movements of air within the atmosphere. These disturbances can affect the aircraft's flight path, causing it to move unpredictably. Several factors contribute to the formation of turbulence. Things like thermals, mountain waves, jet streams, frontal boundaries, and thunderstorms can all produce turbulence. In some cases, turbulence can be so severe that it can cause damage to an aircraft or injure occupants. Wind shear is also a type of turbulence and is one of the most common causes of turbulence. Wind shear happens when there's a sudden change in wind speed or direction over a short distance, especially in the lowest 2,000 feet of the atmosphere. For example, if a plane encounters an area where winds shift from calm to strong or change direction rapidly, it can cause the aircraft to experience turbulence as it moves through the differing air currents. This is especially critical during takeoff and landing. Temperature and density altitude are important factors that affect aircraft performance, especially during takeoff and landing. When temperatures are high, the air is less dense than cold air, which means that the aircraft's engines and wings have to work harder to achieve the same level of performance. The aircraft's engines may produce less thrust because there's less oxygen available in the air. This decreased air density means the aircraft will need a longer runway to take off because there is less lift generated by the wings and less thrust produced by the engines. When air is colder, it is denser, providing more oxygen for combustion, more lift for the wings, and better engine performance. Cold air helps the aircraft generate more lift, and engines produce more power, which can reduce the required runway length for takeoff. It also allows for a better rate of climb since the aircraft has to do less work to generate lift and thrust. The measure of these differences is called density altitude, which is what type of air the aircraft feels like it is flying in, considering both pressure and temperature. In simpler terms, it's a measure of the air density that incorporates both altitude and temperature. At high density altitudes, which occur when it's both high in elevation and hot, the air is thinner, meaning the engine cannot draw in as much air for combustion. This results in reduced engine power and efficiency. In cooler temperatures and at lower altitudes, the air is denser, meaning the engine can produce more power. This leads to better fuel efficiency and overall performance. This is called low density altitude. All of the things we have already looked at can happen by themselves, but can all be found in one place as well, in a thunderstorm. Thunderstorms can significantly impact aviation by causing severe turbulence, wind shear, icing risks, hail damage, and potential disruptions in flight paths due to strong updrafts, downdrafts, and microbursts that they generate. These often lead to flight delays, diversions, and cancellations when flying near or through a thunderstorm. Even a lightning strike, while not typically causing major structural damage to modern aircraft, can still require post-flight inspections and potential delays due to system checks. A lot of things that can happen that can impact aviation when it comes to weather, and each of these things that the weather can produce that we have covered in this video can produce significant problems. We hope this video has provided some information on some of the things that meteorologists have to consider when forecasting for the aviation community. Thank you for spending some time with me. Again, my name is Gene Hatch, meteorologist with the National Weather Service in Springfield, Missouri. Please look for our other Weather Unlocked videos and have a good day.